Re-Source.Society. From the starts, hungry eco-cities paths to progress experiments.
For centuries, humanity has drifted away from nature, trusting technology more than the ecosystems that sustained us.
Agriculture and industrialization grew our cities, yet pushed our lands beyond what they can sustainably give.
Controlled environment agriculture promises to ease that pressure, using less water, less land, and no chemicals, allowing to grow food for the cities, in the cities.
But controlling environments comes at a cost. Heating, cooling, dehumidifying demands large amounts of energy, leaving heavy environmental footprints and expenses.
This raises the question, is there a more resource-efficient way of controlling indoor agriculture environments? Could we reconnect technology with nature's own strategies and create resource-efficient systems that sustainably feed the hungry eco-cities of the future?
We are Instagreen
and Nicolas Rotta,
a sustainable indoor farming company that embraces low-tech solutions,
and an artist devoted to sustainability, regeneration, and social design.
Together, through the Hungry Eco-Cities residency, we set out to explore new ways of climatization, affordable, resource-efficient, and inspired by nature.
This is our project, Re-Source.Society.
We want to work with the environment, not against it.
To better understand it, we studied the physical principles that shape climates: heat, humidity, airflow, plant interactions, and phase changes, biomimicry.
We looked at living systems and created a group of solutions: sweating skin for cooling, lungs for expelling particles, fingers for controlling, nervous systems for sensing, brains for knowing when to activate.
These principles became prototypes, which we tested, refined, and tested again, until we felt that nature, technology, and art started working together.
The cactus. Evaporative cooling is nature's oldest air conditioner. From our skin releasing sweat to cool down, to leaves breathing out moisture. The cooling cactus provides low-energy cooling. Inside its terracotta body, air and water flow through an internal tube system. Evaporation and cooling happens within, while the glazed skin seals humidity inside. The moist exhaust air is expelled outdoors, cooling the space without raising indoor humidity.
In tests, thermal imaging showed a cooling capacity of 0.6 kilowatt-hours per square meter, an efficient and low-tech way to lower the temperature.
The lung. Humidity moves in the air from water vapor-dense areas into regions with less vapor. This process is driven by vapor pressure gradients, not just relative humidity. This means that even outside conditions that seem unfit for ventilation could be used for passive dehumidification of an indoor space.
Think of your skin in winter. Even in damp, cold air, it still dries out, because the cold air around you carries almost no water. The living lung works the same way. Dry or cool outdoor air flows through a textile membrane. Water vapor diffuses from the room into the inner airflow of the lung and leaves the space, expelling the humidity without changing the room temperature.
This lets indoor humidity drop even when it's too cold or damp to ventilate. No ventilation, no heat loss, just passive humidity transport. At Instagreen, the living lung lowered indoor humidity and cut dehumidifier energy use by about 20%.
Brain. Every body needs awareness. Our climatic artifacts are connected through a digital brain, a system of sensors and logic that reads the air, understands its rhythms, and activates each device when the time is right. A nervous system and brain for a living architecture.
To imagine how this system can live elsewhere, we created digital twins. Grasshopper and HTML simulations analyzed local weather and microclimates, mapping how each device should adapt to different seasons, farms, and locations. Fed by real-world measurements, These models generate new shapes, letting our prototypes grow into visions for buildings, districts, and even cities.
These shapes help us with new ways of thinking, how we can dance with nature's changes and harness what the environment offers while keeping controlled environment agriculture truly controlled. For small local farms, they reduce the use of natural resources, cut costs, and build resilience. For the food system, they chart a path where farming breathes with its environment, not against it.
They remind us, innovation isn't only about efficiency, it's about reimagining our relationship with natural resources.
In the future, these ideas can evolve, scale, and inspire others.
For us, this residency has shown the value of bringing together nature, technology, and art to plant seeds of lasting change.